and Assalamualaikum IB to all of you. So my name is Muhammad Syamil Naim and this is my fellow teammates Haris, Danish and Farhan. So in this video, we will be presenting about two topics, which is related rates, where we focus on rate of change, and the second one is applied maximum and minimum problem.
Application of differentiation. There is 5 types of application, which is related rates, maximum and minimum problems, determining increasing and decreasing function, Ross theorem, and the last one is mean value theorem. What is differentiation? Differentiation is a method of finding the derivative of or rate of change of a function. The rate of change of function defined as dy over dx equals to fx equals to y. Related rate or rate of change. In the differential calculus, related rate problem involves two or more variables that changes at the same time, possibly at different rates. The objective is, in a related rate problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity. Second, the procedure is to find an equation that relates to the two quantities and then use the chain rule method or implicit method.
The problem statement of rate of change. Wheat is put into a conical pie at the rate of 20 cm cubed over a minute, whose bottom radius is always half of the height. How fast will the area of the base be increasing when the pile is 16 cm height? So it is given that the volume of the conical pie is equal to 1 over 3 pi r square h. It is given that the volume over time, or dV over dH, is 20 cm cubed over minute. What is the area over time, or dA over dt, when the h is given, which is 16 cm? So, in this case, the first step is to identifying the unknown. Note that the area of the base of the cone is a circle. So, dA over dt is equal to dA over dV times dV over dt, which is equal to dA over dr times dr over dV times dV over dt. The second step is to differentiate the formula and find the area. Note that the bottom radius is always half of the height. The r is equal to h over 2, so the h is 2r. Now, we need to differentiate the formula. The area of circle is pi r squared, so the dA over dr is 2 pi r. Next, the volume of cone. The volume of cone is equal to 1 over 3 pi r square h. We differentiate the volume of cone and we'll get dV over dr is 2 pi r squared. The dA over dt is 2 pi r times 1 over 2 pi r squared times 20, and we'll get 20 over r. When the h is 16, the r is 16 over 2, which equals to 8. So the dA over dt is 20 over 8, and the final answer is 5 over 2 cm squared over minutes. So the conclusion of rate of change. Related rates are important because often one variable's rate over time will impact another variable's rate over time. If one rate is known, it can be determined how the other variable is changing using calculus.
Next is, for topic 2, we have applied maximum and minimum problems. The introduction for applied maximum and minimum problem is, the process of finding maximum or minimum values is called optimization. Many application problems in calculus involve function to find maximum or minimum values. In real life, we usually use to maximize the profit in a company or minimize the cost of make a particular object. While in calculus, we use applied maximum and minimum problems to calculate the highest and lowest point of the curve in the graph or to know its turning point.
And for the second problem is a closed cylindrical fuel tank of radius of x cm and height y cm has a surface area of 200 pi meter. And so for the question A is we need to express y in terms of x, and for the question B we need to prove that the volume of the cylinder is V equals to 100 pi x minus x pi cube. And for the question C, we need to find the value of x such that the volume of the cylinder is maximum. For question A, we know that the surface area of cylinder is 2 pi r plus 2 pi r h, and this is equals to 200 pi. And we also know that radius is equal to x and height is equal to y. And from that, we got 200 pi equals to 2 pi x square plus 2 pi xy. And from that, we want to get the y to the subject. And from that, we need to move it to the left. And we get negative 2 pi xy equals to 2 pi x square minus 200 pi. And we need to divide it with negative 2 pi x, and so we can get y equals to x square minus 100 over negative x, or equivalent to y equals to 100 minus x square over x. For question B, we need to prove that the volume of the cylinder is V equals to 100 pi x minus pi x cube. And we also know that V equals to pi r square h. And we need to substitute h with the y, which is 100 minus x square over x. And then we get pi x square times 100 minus x square over x. And from that, we get 100 pi x minus pi x cube. And to solve question C, we need to do derivative, which is we get dv over dx equals to 100 pi minus 3 pi x square. And we need to put it into a linear equation, and we get x equals to minus 5.77 and x equals to most positive 5.77. In this situation, we need x as positive value. So we choose x equals to 5.77 and do the second derivative and got minus 6 pi x, which is less than 0, and it indicates maximum value. Thus, x equals to 5.774 is a maximum value. So, conclusion for applied maximum and minimum are applied maximum and minimum are important because by using the formula and accomplishing both first and second derivative, it can give us a solid answer either in maximum or minimum value.